Darlington interfollower circuit. Darlington interfollower circuit. Okay. In some applications, the need arises for an amplifier with a high input impedance. For input impedance smaller than about 500 kilo ohms, that is Ri less than 500 kilo ohms, the emitter follower is a satisfactory one. To achieve larger input impedance, the circuit shown in figure called Darlington connection. This is the Darlington connection. Consists of two composite transistors. Two composite pair transistors. This one is Q1 and this one is Q2. Emitter of Q1 is connected to base of Q2. The collector of these two transistors are connected like that. This is called as a Darlington connection. The Darlington circuit consists of two cascaded emitter followers with infinite emitter resistance in the first stage. Two emitter followers. This is the emitter follower 1. One is emitter follower 2. Collector is connected to ground. Emitter of the first stage is connected to base of the second stage. Here RC1, RE1, not RC1, RE1 is set to infinity. In the definition, the Darlington circuit consists of two cascaded emitter followers with infinite emitter resistance in the first stage. This one is the infinite emitter resistance in the first stage shown in figure. This one is a Darlington emitter follower. Definition is two cascaded emitter followers. This one is emitter follower 1. This one is emitter follower 2. Two cascaded emitter followers shown in figure. Find out the input resistance, output resistance. Find out overall input resistance Ri, output resistance R0, overall current gain AI, overall voltage gain is AB, and these are the some important parameters related to not characteristics related to Darlington emitter follower. Need to calculate these parameters Ri, R0, AI, AB. These are some important characteristics of the emitter follower. Consists of this Darlington emitter follower consists of two stages. Analysis is starting from second stage. For the second stage, assume that HOE into RE less than or equal to 0.1 and HFE RE greater than HIE. Consider second stage. Assume that HYE into RE less than or equal to 0.1 and HFE into RE greater than HIE. Therefore, we use approximated H parameter model. Approximated CE H parameter model. These two are in common collector configurations. The current gain AI is equal to general formulas or exact formulas. From that only you have to derive the approximated H parameter models. AI is equal to minus HFE by 1 plus HOC into RL. Current gain. Next one, input resistance formula RI is HIC plus HRC AI into RL. These are the exact model characteristics, current gain and RI. Some conversion formulas are also there. HFC is equal to minus of 1 plus HFE. RI is equal to, not RI, HIC is equal to HIE. HRC is equal to 1. HOC is equal to HOE. Therefore, substitute these conversion formulas in that above equation. AI is equal to minus of HFC is equal to minus of 1 plus HFE, minus plus 1 plus HFE by 1 plus HOC is HOE into RL. Next, input resistance RI is equal to HIC is equal to HIE. HIC is equal to HIE plus HRC is equal to 1 current gain AI into RL. Next one. Consider second stage. Consider second stage. Consider second stage. The current gain for the second stage is AI2. For the second stage, the analysis HO, assume that HOE into RE less than or equal to 0.1. HOE into RE less than or equal to 0.1. Therefore, HOE into RL is RE is neglected. Therefore, current gain AI2 is equal to 1 plus HFE. 1 plus HFE by 1 plus HOE RL is HOE into RE less than or equal to 0.1. Therefore, AI2 is equal to 1 plus HFE. AI2 is equal to 1 plus HFE. That is output current I0 by input current I2. Therefore, AI2 is equal to output current I0 by input current I2 is equal to 1 plus HFE. Next, find out input resistance of the second stage is RI2. Let it be RI2. That is HIE plus AI2 into RL is RE. This is the formula. RI is equal to HIE plus AI into RL. For second stage, RI is RI2. HIE plus AI is AI2 into RE. This one is the input resistance of the second stage. And this one is input resistance of the second stage, RI2. RI2. RE is the load resistance. AI2 is equal to current gain of the second stage, output current I0 by input current I2. Here RI2 is equal to AI2 into RE. AI2 into RE is far greater than HIE. Therefore, HIE is neglected. AI2 is 1 plus HFE into RE. This is the input resistance of the second stage. The effective load resistance of the Q1 is this is the For the second stage, Ri2 is equal to V2 by I2. V2 by I2 is equal to 1 plus HFE into Re. This Ri2 acts as load resistance for the first stage. Since the effective load for Q1 is Ri2, the effective load for Q1 is the effective load for Q1 is Ri2, which is very high value. 1 plus HFE times Re. Suppose Re is equal to 3 kilo ohms, 1 plus HFE is equal to 100. 100 into, suppose HFE is equal to 100. Re is equal to 2 kilo ohms. Therefore, Re2 is equal to 101 times 2 kilo ohms. Therefore, which usually does not meet the requirement HOE into Ra2 less than 0.1. Ri2 acts as load resistance for the Q1. Test the condition. Test the condition is HOE into load resistance for the first stage is Ri2 is not less than 1, is greater than, not less than 0.1, is greater than 0.1, because Ri2 is equal to 100 times 2K. 100 times 200K. 200K. Here HOE into 200K is not less than 0.1, is greater than 0.1. That is the reason we use exact H parameter analysis. We use exact H parameter analysis for stage 1. For stage 2, we use approximated H parameter model, because HOE into Re less than, assume HOE into Re less than 0.1. Here, AI1 current gain formula is equal to I2 by I1. I2 by I1. Current gain formula AI is equal to I2 by I1. For stage 1, I2 is the output current, IA not I1. IA is the input current. Therefore, AI1 is equal to I2 by IA. AI is equal to I2 by IA. We use formulas minus HFC by 1 plus HOC into RF. We use conversion formula. HFC is equal to minus of 1 plus HFE minus plus. That is equal to 1 plus HFE by HOC is equal to HOE. Conversion formulas. We use conversion formulas. That is RL. AI 1. 1 plus HFE by 1 plus HOE into RL is Ri2. RL is Ri2. Substitute Ri2 in that expression. 1 plus HFE by 1 plus HOE. Ri2 is 1 plus HFE into Re. 1 plus HFE into Re. That is equal to 1 plus HFE by 1 plus HOE into Re plus HOE HFE into Re. We know that HOE into Re less than 0.1, that is neglected. Therefore, AI1 is equal to 1 plus HFE by 1 plus HFE by this entire term. This one is less than 0.1. 1 plus HOE HFE into Ra. This is the AI1. What about overall current gain? AI. Overall current gain AI from the circuit is overall current AI from the circuit is output current I0 by input current II. Intermediate current is I2. AI is equal to I0 by IA. AI is equal to output current I0 by input current II. Numerator and the denominator is multiplied with I2. This one is I2, this one is I2 by IA. AI1 is equal to I2 by IA. AI1 is equal to, this one is AI1. I0 by I2 is AI2. Therefore, overall current gain of the Darlington emitter follower is AI is equal to AI2 into AI1. AI2 is equal to already derived 1 plus HFE. AI1 is 1 plus HFE by 1 plus HOE HFE into R. Therefore, overall current gain AI is equal to 1 plus HFE whole square by 1 plus HOE HFE into R. This is the overall current gain of the emitter follower, Darlington emitter follower. Next one is overall input resistance. Overall input resistance. Overall input resistance from this figure. This is the overall input resistance Ri. Ri is equal to Vi by Ii. Ri is equal to Vi by Ii. That is also called as input resistance of the first stage. Either Ri1 or Ri is equal to Vi by V1 by Ia. V1 by Ia. We know that the formula, general formula, Ri is equal to HIC plus HRC, current gain A into load resistance Rn. For stage 1, Ri is the input resistance of the stage 1. In this figure, Ri is the input resistance of the stage 1. Ri2 is the load resistance of the stage 1. AI1 is the current gain of the stage 1. This one is Vi, not V1. Here Vi by Ri. Vi by Ii. Ri1. This one is Ri1 or power of input resistance Ri. HIC is equal to, use conversion formula, HRC is equal to 1. AI1 into RL is Ri2. Ri2 is the input load resistance of the first stage. That is equal to HIE. AI1 is equal to, we know that AI1 is equal to 1 plus HFE whole square by 1 plus HOE HFE RE. Ri2 is 1 plus HFE into RE. That is equal to AI1 is equal to, we know that AI1 is equal to 1 plus HFE by, square is not there. HIE plus 1 plus HFE whole square RE by 1 plus HOE HFE into RE. This is the equation for the input impedance of the Darlington circuit is valid for HOE less than or equal to 0.1. Therefore, Ri or Ri1, Ri or Ri1 Ri or Ri1 is equal to this term is far greater than this term. Therefore, 1 plus HFE whole square RE by 1 plus HOE, HFE into RE. Input resistance of the Darlington circuit is valid for HOE into RE less than or equal to 0.1. Input resistance of the Darlington circuit is valid for HOE into RE less than or equal to 0.1. Consider example, suppose RE is equal to 4 kilo ohms, HIE is equal to 1.1 kilo ohm, HFE is equal to 50, HRE is equal to 2.5 into 10 power minus 4, HOE is equal to 25 micro ampere per volt. These values are substituted in the above equation. Ri is equal to generally HIE plus 1 plus HFE whole square RE by 1 plus HOE HFE into RE. All these values are substituted in that equation. Got 1.73 mega ohms. HFE is equal to 50. 50 plus 1, 51 whole square. RE is equal to 4 kilo ohms. HOE is equal to 2.5 10 power minus 4. HFE is equal to 50. RE is equal to 4 kilo ohms. HIE is equal to 1.1 kilo ohms. All the values are substituted. We will get input resistance is in the order of mega ohm. What about overall current gain? Overall current gain A is equal to already derived. A is equal to 1 plus HFE whole square by 1 plus HOE HFE into RE. This value is A is equal to substitute all these parameters in that equation. Therefore, A is 427. A is 427. This is the overall current gain already derived. 1 plus HFE whole square by 1 plus HOE into HFE into RE. Compare these values in a single stage. Single stage interpolar is nothing but two common color configurations are cascaded. In case of single stage, Ri2, Ri in case of single stage. Second one, Ri2 is equal to 1 plus HFE into Re. 205K. 205K. A is equal to 1 plus HFE. A is equal to 1 plus HFE, that is 50 volt. For single stage, these values input resistance. Input resistance is nothing but second stage, consider second stage input resistance. 1 plus HFE Re, 205 kilo ohms. For cascaded stage, Ri is equal to 1.73 mega ohms. The current gain for the cascaded Darlington interpolar circuit is 427, here 51. Next one, voltage gain. Voltage gain. Voltage gain is equal to, we know that general formula. We use general formulas. AB is equal to current gain into load resistance RL by input resistance Ri. And Ri is equal to HIC plus HRC A Ri. For conversion formulas, HI is equal to HRC is equal to 1 A into Ri. From this expression, Ri is equal to Ri minus HI. Substitute in that expression, ARL is equal to AI This one is RL, not RI. This one is RL. This one is RL. A into RL is equal to RI minus HIE by RI. That is equal to 1 minus HIE by RI. 1 minus HIE by R. For stage 1, voltage gain AB1. For stage 1, voltage gain is equal, voltage gain is AB1 for stage 1. General formula is AB is equal to 1 minus HIE by EB is equal to 1 minus HIE by RI. For stage 1, EB1 is equal to 1 minus HIE by RI1 or RI. Both are same. RI1 or RI. For stage 2, stage 2, voltage gain is AB2. Therefore, AB2 is equal to 1 minus HIE by input resistance for the stage 2 is RI2. Input resistance for the stage 2 is RI2. Overall gain AB is equal to AB is equal to AB1 into AB2. AB1 into AB2. Because here, why AB1 into AB2? Overall gain is voltage gain. Here, AB is equal to V0 by VI. Intermediate voltage is V2. V0 by V2, that is V2 by VA. V0 by V2 is AB2. V2 by VA is AB1. Multiply both gains. AB is equal to AB1 into AB2. AB1 is equal to 1 minus HIE by RI1. AB2 is equal to 1 minus HIE by RI2. For the transistors, both the transistors are identical, but some difference is there. That is the reason we use HIE1 and HIE2. 1 minus HIE1 by RI1, 1 minus HIE2 by RI2. In case of Darlington configurations, we need to HIE1 is equal to 1 plus HFE into HIE2. This is the very, very important equation. Substitute this equation in that expression. 1 minus HIE1 is 1 plus HFE into HIE2. RI1 is equal to already derived that expression, 1 plus HFE whole square RE by 1 plus HY HFE into RE. By term is replaced with here by 1 plus HOE HFE RE. This one is 1 minus HIE2 by RI2. RI2 expression already derived. RI2 is equal to 1 plus HFE into RE. RI2 is 1 plus HFE into RE. This is the expression. That is equal to 1 plus HFE cancel. 1 minus HIE2 into 1 plus HOE HFE RE by 1 plus HFE into RE. This one is 1 minus HIE2 by 1 plus HFE into RE. LCM parameter is simplify this expression. 1 plus HFE RE minus HIE2 1 plus HFE into RE. 1 plus HFE into RE. Here RE, HFE RE minus HIE2 minus HIE2 HOE HFE RE by 1 plus HFE RE. This is the entire term. This one is 1 minus HIE2 by 1 plus HFE into RE. These are the RE plus HFE RE minus HI2 need not write entire expression here. One plus HFE into RI is RI2. That is 1 minus HIE2 by RI2. This one is generally 1 minus HIE2 by RI2. 1 minus HIE1 by RI1. 1 minus HIE1 by RI1 minus HIE2 by RI2 minus into minus plus HIE1 HIE2 by RI1 RI2. Both resistance are RI1 and RI2 are far greater. Therefore, this term is neglected. Therefore, AB is equal to 1 minus HIE1 by RI1 minus HIE2 by RI2. That is 1 minus HIE1 by RI1 plus HIE2 by RI2. That is equal to 1 minus HIE1 is, we know that HIE2 into 1 plus HFE. RI1 is 1 plus HFE whole square RE into here 1 plus HOE HFE RE plus HIE2 by RI2 is 1 plus HFE into RE. That is equal to this cancel here. 1 minus HIE2, here HIE2 and HOE, HFE, RE, HIE2 plus HIE2 by 1 plus HFE into RE. That is equal to 1 minus 2 HIE2 plus HOE, HFE, RE, HIE2 by 1 plus HFE into RE. Here 1 minus HI is the HIE2 is the common term. 2 plus HOE, HFE, RE by this one is RE2. 1 plus HFE RE is RE2. This is the voltage gain AB. Voltage gain AB expression is from, calculation is from this one. Above one is some lengthy procedure. Need not go for this procedure. Some lengthy procedure here. This is also lengthy procedure. That is the reason AB is equal to V is 1 minus HIE1 by RI1 minus HIE2 by RI2. Multiply these terms. This term is neglected. Next one is output impedance. For the calculation of output impedance, analysis is from left to right, first stage to second stage. This one is output impedance. Output impedance. We know the general formula Y01 is equal to HOC minus HFC, HRC by HIC plus RS. For stage 1, general output impedance. We use exact analysis for stage 1. HOC is equal to HOE, HFC is equal to HRC is equal to 1. It is equal to HFC by HIC is HIE plus RS. That is HOE, HFC. HFC is equal to minus of 1 plus HFE. 1 plus HFE, HIC plus RS. That is equal to HOE into HIE plus RS 1 plus HFE by HIE plus RS. We use HIE1, HOE into HIE plus neglected, HOE into RS 1 plus HFE. This term is neglected. 1 plus HFE by Y01. Y01 is equal to 1 plus HFE by HIE plus RS. R01 is equal to HIE1. For stage 1, HIE1 RS by 1 plus HFE. For stage 2, output resistance R2 is equal to RS2 plus HIE2 by 1 plus HFE. RS2 is this one. RS2, R01 acts as a source resistance for the second stage. Therefore, RS2 is replaced with R01, that is HIE1 plus RS by 1 plus HFE HIE2 by 1 plus HFE. That is equal to HIE1 plus RS by 1 plus HFE whole square, HIE2 by 1 plus HFE. HIE1 is, we know that HIE1 is 1 plus HFE into HIE2 plus RS by 1 plus HFE whole square plus HIE2 by 1 plus HFE. That is equal to, multiply this one, HIE2 by 1 plus HFE whole square, HIE2 plus RS by 1 plus HFE whole square. Next one is HFE, HIE by HIE2 by HIE2 by HIE2 HFE by 1 plus HFE whole square. This one is HIE2 by HIE2 by 1 plus HFE, RS by 1 plus HFE whole square. Next one is 1 plus HFE, HIE2 by 1 plus HFE whole square. That is 1 plus HFE, 1 plus HFE whole square. One time is cancelled. Finally, HIE2 by 1 plus HFE. Therefore, 2 times HIE2 by 1 plus HFE plus RS by 1 plus HFE whole square. This is the output resistance for the stage 2. Darlington interfollower has high input resistance and a voltage gain less, close to unity. And output impedance of the Darlington circuit may be greater than or smaller than that of single transistor interfollower, depending on the value of RS. Depending on the value of RS, this R2 changes. If RS is equal to 0, RS is equal to 0, R02 is equal to twice HIE by 1 plus HFE. If RS is equal to 0, then R0 for the Darlington connection is the twice R0 for a single stage follower. Darlington interfollower has a high input impedance of the order of mega ohms. It has a large current gain is the order of 10,000 range. Very low output resistance of the order of few ohms. The value of RS R not depends on RS value. Circuit voltage gain AB is less than 1. These are the some characteristics of the Darlington interfollower.